Okay. So what happens when we have a function? When we have a function, what we do is it's function sort of like the machine, or usually in algebra, it's the expression. So you have an input. You're going to input something into the expression. You're going to input something into the machine. You're going to put in something, and usually it's for the x, right? In the expression, there's usually a variable. You're inputting something, some value into that variable, and then you're getting an output from it. So let's write this down. Function. We'll take an input, and it will put it through an expression and will produce a given output. So it usually has something like this. We input some value, it goes through the function, and then it will output something from that. In a function, the independent variable, and I'll explain this in a minute, the independent variable has exactly one dependent variable. In a function, the independent variable has exactly one dependent variable. So now that independent variable, what does it mean to be independent? Not relying on anybody else, right? If you're an independent person, you don't need anything. You could function all on your own. Well, so that's the idea of the independent variable. Usually that's the x. So that's saying this number is not based on anything else. This number is just coming from anywhere. It doesn't really rely on anything else. But once that independent variable, once that independent number or whatever it is gets put into the function, it is going to come out with an output. Now that output, usually the y, that's completely dependent. So dependent is the opposite of independent. If you're dependent on somebody, you rely on them. That output that we're getting once it goes through that function is completely dependent on what we initially put into the function. So let me give you an example. So let's say I say f of x is equal to, and I'm going to say x squared if x is even, and x plus 5 if x is odd. So this whole f of x is the name of the function. Now, it doesn't have to be f of x. It could be any two variables under the sun. It could be h of a. It could be q of r. It doesn't matter. Whatever's inside the parentheses, that's your input. This is your general input. So now, this is our general function rule. This is our function, f of x. This is sort of like the machine that it's going into. It's going into x squared if x is even, and it's going to go into x plus 5 if x is odd. So now let's say, well, I want you to find f of 2 based on my function rule. So my input is 2. Is 2 even or odd? Even. So am I going to plug it into x squared, or am I going to plug it into x plus 5?
X squared.
X squared, because 2 is even. So it said plug it into x squared if it's even, plug it into x plus 5 if it's odd. So f of 2 is going to equal 2 squared, which is 4. So 2 was my input, and 4 is the output. X squared was the machine, the function machine. Well, now let's say I ask you to find f of 3. Well, now is 3 even or odd? 3 is odd. So which one, which expression am I plugging into, x squared or x plus 5? X plus 5. So what are we doing? We're doing 3 plus 5, which is going to output 8. So my input was 3. My output was 8. In this, f of 3 equals 8. Out of these numbers, which one is my independent and which one is the dependent? F of 3 equals 8. Which one's independent? What's your name? I'm sorry, Erin?
Yeah.
Okay, Erin?
The input is the independent and the output is the
Good. The independent is the input, the input is the independent, the output is the dependent. Why? I just chose 3, right? I just picked a number. I said input 3 into our function machine. But that 8 was completely dependent on whatever number I input into that machine. Okay, and now some people have a hard time in understanding what this really means. In a function, the independent variable has exactly one dependent variable. And that's what makes a function a function. If the independent variable has 2 different dependent variables, then it is no longer a function. It is not considered a function. So, you know, I'm going back to how my teacher explained it to me, and it was always what stuck. So let's say we have some people, and they have birthdays. Let's say I have Susie, Edgar, Sally, I don't know, Pete. And I have the birthday 6/23, 10/4, and I don't know, 8/5. All right, so let's say Susie's born on 6/23. Edgar is born on 10/4. Sally is born on 8/5, but Pete is also born on 8/5. This is still considered a function. Why? Is there any way Susie can have 2 different birthdays? There's no way. Susie is a person, she was born on one day. She cannot physically be born on 2 different days. It's impossible. So this is a function. Is it okay that both Sally and Pete are born on the same day on 8/5? Absolutely. That's okay. So so basically, if the people are our x's, our birthdays are our y's. So our input is x, our birthday is our output. We can repeat our output, but we cannot repeat our input. So we can repeat the y, but we cannot repeat the x. That's what this means. Okay, sometimes functions could just be a very general rule. So for example, I can say h of a is equal to the next largest number that starts with the same letter as variable a. So this is my function. My function is the machine is the next largest letter that starts with the same letter as the variable a. So now let's put an input for a. So let's say I have h of 2. So based on my function machine, they're saying, okay, choose the next largest number that has the same first letter as 2. Well, what's the first letter in 2? T. So what's the next largest number that has the letter T as its first letter? 3. So h of 2 is 3. What about h of 8? 8 starts with an E. So the next largest number that comes, 11. You got it. Right. Like I said, functions are just a very general rule, a way to state a rule. So we have y is equal to x plus 1. This is the same exact thing as saying f of x is equal to x plus 1. Do you guys remember that the y and f of x are interchangeable? Because y is our output, f of x is just another way to represent that. So our output will equal whatever we put into x plus 1. If I'm going too fast, just tell me to slow down. Okay, so now we spoke all about what a function is. Let's talk about what's not a function. In a function, an input has exactly one output. So if an input has more than one output, it is not a function. Okay, let's look at an example. Let's say I have x squared plus y squared is equal to 4. Think back to Algebra 2. Does anybody know what this represents, this equation? What shape? A triangle? Not a triangle, no. X squared plus y squared. Buddy. No? Okay, this is a circle. X squared plus y squared equals 4. This is a circle. So remember, the standard form of a circle is x minus h squared plus y minus k squared equals r squared. All right, we're going to be talking. What is this? All right. Well, all right. I won't confuse you with all that. We'll talk about the different things we need to know how to graph a little later in the chapter. Don't worry just yet. All right. So you don't need to know this is a circle. How about that? You don't need to know this is a circle. But we can still decide whether this is a function or not. How am I going to decide whether this is a function? I'm going to choose a number to input in. Choose 1. Are you guys all okay with choosing 1? Let's input in 1. So if I input in 1 for x, what I'm going to do is I'm going to have 1 squared plus y squared equals 4. One squared is 1. 1 plus y squared is equal to 4. We now need to solve for y. Who remembers how we solve this for y? What should I do first? Subtract 1. Yeah, we're going to subtract 1 on both sides. And then when I subtract 1, I'm going to have y squared is equal to 3. Now, I need to get y. I don't want y squared. To undo a square, what must we do? Take the square root. But this was always a big thing in Algebra 1. Do not forget, once you take the square root of a number, it's not just a positive value. What else is it? Positive and negative. Like the square root of 25, if x squared equals 25, x could equal positive 5, but can it also equal negative 5? So this is going to equal plus or minus root 3. What do I want you to realize? I input the number 1. Once I input that number 1 and I simplify down to find my output gave me positive root 3 and it also gave me negative root 3. So my input gave me 2 different outputs. Is that a function? No. So that means this is saying Sally was born on June 23rd and August 5th. Is that possible? It is not possible. So this is not a function because 2 outputs. All right, let's do some practice with this. Determine if the following are functions. Let's write this out. Determine if the following are functions. All right, so that little squiggly bracket just means I'm opening up a set. So I have a set of points. I have 2, 3, 3, 4, 5, 4. Which one are we not allowed to repeat? Are we allowed to repeat the x or are we allowed to repeat the y? Good. So put a little star here. Never repeat x. Repeating y is okay. Okay. Because remember, Sally and Pete can both be born on June 23rd. Right? That's okay. Repeating the output is okay, but you can't repeat the input. All right. So remember, in every coordinate, it's an x comma y. So x, y, x, y, x, y. So all we care about is not repeating the x's. I have 2, I have 3, I have 5. Were any x's repeated? No. So is this a function? Yes, because no x's were repeated. So I'm going to write yes function, no repeat x. All right, let's try another one. So now I'm giving you the set of points 2, 3, 2, 4, 3, 4. All right, let's take a vote. How many people say this is a function? How many people say it's not a function? Good, you all win. Why is it not a function? What has been repeated? Good. Here we have, oops, don't mean to squiggle that out. We have the 2 repeated here, the 2 repeated here. So we're going to say not a function, repeat x. Does anybody remember how you determine if something's a function given a graph? Does anybody remember? What's your name? Kimberly. The vertical line test, you got it. So let's talk about that. All right, so this is supposed to be a circle. And circle's like your biggest culprit of not being a function. It's like everything a function doesn't want to be is the circle. So case in point right here, when x is 0, do we see that? When x is 0, what happens? Y is positive 2 and y is also negative 2. When x is 0, y is positive 2 and y is also negative 2. So what the vertical line test, it basically lets you know if we're gonna hit multiple outputs for the same input by just creating the vertical lines. So by me creating vertical lines, what has happened? I touched my circle here, and didn't I also, that vertical line also touched the circle there? That means for whatever x this is, I have 2 y values. So this immediately just continues to fail that vertical line test. And if it fails the vertical line test, it is not a function. What do we think? Is this a function or not a function? This is absolutely a function. It passes the vertical line test. Function or not a function? What do y'all think? No, this is just one part of the vertical line, right? It's just like, there's nothing there. There's not even a chance of it maybe being a function. This is absolutely not a function. All right, what do you all think? Function, not a function? Function, you got it. It completely passes the vertical line test. A horizontal line is a function. All right, the very last thing we're going to do today is we're going to decide, is the given, is it a function given its equation, given its expression, without graphing it, without inputting anything? It's figuring it out from just its equation alone. So, is the equation a function? So there's some steps we should take. First step, solve for y. If there is only one solution for the given x, then it is a function. And you'll see what I mean once we do a problem. So we're going to decide if the following are functions. All right, the first one. 3x plus y equals 1. So the algebra 2 really helps in this part because it saves you a lot of time if you know. So does anybody know what this is an equation of, even though it's not in its right format, just by looking at it? What's your name?
It's a line.
It is a line. What's your name?
Ion.
Ion?
Yeah.
All right, good. This is a line. Y equals mx plus b, right? So you have an x, you have a y, you have a constant. No exponents on this. This is absolutely a line. And our lines, visualize a line, right? A line usually goes like this or like this. Does that pass the vertical line test? Yes. So will this be a function? Yes. But let's say you didn't go back into your algebra 2 zone and you couldn't visualize that this was a line, so you didn't know if this was a function or not. What did I tell you to do? Go to your equation and solve for which variable? Y. So I'm going to now go and I'm going to solve for y, meaning I need to get y all by itself. For me to get y all by itself, don't I have to subtract that 3x over? Yeah, so I'm going to have y is equal to negative 3x plus 1. Is there a plus or minus here showing that there's going to be two different versions of it? No. They're saying every y will equal this. There's not a positive and negative version. This is all it equals. So is this a function? Yes, this is a function because there's not two different versions of my output. So let me write that out. any x you input will give you exactly 1y. So this is a function. All right, let's try this next one. Negative 4x squared plus y squared minus 9 is equal to 0. I don't expect you to know what this is, even though you learned what this is in Algebra 2 if you manipulate it. But that's okay. Don't even worry about that. Let's just follow what I said to do. I said take your equation and solve for what? Y. In order to solve for y, you need to get it completely by itself. So the first thing I'm going to do is add over that 9. So now I'm going to have negative 4x squared plus y squared equals 9. What else should I do to get y by itself? Add 4x squared, you got it. So now I'm going to have y squared equals positive 4x squared plus 9. Y is still not by itself, it's squared. How do you undo a square? You take the square root. But the minute you take the square root on both sides in an equation, what do you have to account for? Plus minus. So y is equal to the positive and negative value of 4x squared plus 9. The minute this is saying y equals the positive root of 4x squared plus 9, but it also equals the negative root of 4x squared plus 9, what does that tell you? It has two different ones. So is this a function? No, not a function. All right, there is more to this lesson. We haven't even entered in domain and range, but I think that's enough for one day. We'll stop here. We'll pick up more next class. Y'all can get your phones.